So our next speaker is going to also continue on this amazing theme of call center data.
You lucky people.
You're going to never want to make another call to a call center again after today.
It's funny, after working on this project, every time I call up a call center, I wonder if I ended up on some database somewhere. I want to try and find myself in the data records we have.
So it will be Richard Roberts, and his title is, if the program is updated according to whatever I wrote there, RiverState, a visual metaphor representing millions of time-oriented state transitions. Say that 10 times fast.
Go. Okay, thank you very much, Bob. So, yeah, you've almost sort of had an introduction to this already, because Dylan here and I, well, we're working on the same project. Well, I say the same project, we're working on the same data set. There are so many different aspects to this data set. It's such a big data set that I think we could have a few more PhD students working on it for a number more years, and there wouldn't be any overlap. So this project, so RiverState, a visual metaphor representing millions of time-oriented state transitions. So what we're focusing on here is the transition between the states, and by states we mean waiting in the queue, talking to an agent, that sort of thing. So, yeah, as we already said, it's an industry-provided data set. Paul, who is currently in the tutorial, works for QPC, and they provide us with this data. Yeah, Dylan's already discussed the data here, so I don't have to necessarily go into too much detail, but essentially the things we're focusing on here are the 7 main types of transition. So IVR, the interactive voice response, is when you call a call centre, and it says, well, press 1 to go through to this department, press 2 to this department, and it routes you through and puts you in a queue, and you end up talking to the right people, hopefully. So that's the IVR. Queue, agent. So queue is self-explanatory. Agent is when you're talking physically to a person. Hold is when you're talking to an agent, but you're placed on hold, so the agent is trying to sort things out, so it's slightly different to queue. And then there are 2 types of consult call, inbound and outbound. And that's essentially when one agent has to call up another agent because they need advice or information, or they need someone else to process something. And then there's a call end state. So we essentially want to visualize the customer journey as they, from the moment they pick up the phone for the first time, they'll go into the queue, they'll speak to an agent, hopefully have their problem resolved. But even if they hang up and their problem isn't resolved and they call back, we want to sort of link that together. If they have multiple calls, we want to aim for that. So, as I say, it's state transition diagram. So this might be what you might think of a state transition diagram with our current data. We'll have arrows pointing from one to the other, and you might be into the queue, and you might talk to an agent, and they might hang up, or they might, it's a little bit complicated, it's somewhat convoluted, and there are limitations to this. You can't see what time step, for example. If you could say, oh well, they're currently at this state, in this state. You don't know how many times they've gone around this maze before they've reached that point. You can probably apply weighting to the edges of these things to work out the volume, but again, it's difficult because the volume won't account for this sort of time step variable. So what we're doing here, we're sort of arranging them on this sort of axis. It's almost like a parallel coordinates axis. It ends up being more a modified Sankey diagram, where one state transitions into the next state, transitions into the next state, and we use the thickness of the edge to show sort of the volume of calls. And this is what it looks like. So we've got labels here to represent each state. It looks a little bit complicated here because actually this axis here, the agent state, can be broken down into lots of different types of agent states. So that's the department that they're speaking to. So there's, there's a billing department and a marketing department and a retention department, and there's lots of different departments they could be speaking to. So there's a way we can break down this agent state into multiple different ones to sort of analyse further. In this case, the colour is mapped to the average agent duration, isn't it? Yes, average agent duration. As I say, the thickness of the edge here shows the volume of calls. So everybody enters into the IVR. About half of them end up by hanging up straight away. And then you can see this at the bottom here, coming from the call end back into the IVR, and that's the proportion of callers who call back after hanging up within sort of the time frame we have. I will note that Dylan's software visualizes the whole month of data. This is actually, this current one is only visualizing a day, 24 hours worth. It can visualize a bit more, probably not a whole month for memory reasons. That's not a sort of a focus that we've looked at. But it will visualize multiple calls in one go. So yeah, as I said, that we're connecting the customer journey through this line here. So every time a line comes up from call end at the bottom, I'm not sure you're actually going to be able to see that, it's quite far down. Yeah, that's the connection. So the first feature that we found we had to implement is that because so quickly these this vast amount of calls here turn into next to nothing. Hardly anything. You can't really see any patterns or trends there. We had to implement a dimension zooming feature. Let's see if this will load. Is the internet working? Yes, it is. Okay. So yeah, currently, if we were we had to this dimension zooming feature essentially expands these transitions outwards. But the problem we initially found is that this would happen. This would overlap. This would be a mess, and then this wouldn't really show all that much. It would become unhelpful because this overlaps so much. So instead, we implemented this maximum transition width, where the axis would expand, reach its maximum width, and then rather than grow in size, it would change in colour instead. So this is what you can see here. This is changing colour. This is getting darker. While these are growing, but it's no longer overlapping at the beginning. We then also implemented, because obviously that's problematic in that if it's changing in colour, the colour dimension is no longer free for other things. So we implemented a glyph as well, shown here, right. Yeah, we're enabling the glyph. There are two types of glyph. There's sort of this sloping line thing where this glyph expands out, and that's showing sort of how far beyond the fixed transition width it would have grown. So it's essentially just a way of maintaining sort of context of how big that should be while seeing the later transitions. There we go. Okay, so there are, right, let's do this. So there are two types of brushing methods in this software. It does cut it off a bit. So the first one is metadata, or direct state brushing. Okay, so this works very simply by, if you want to look at a specific state, so agent, queue, you click on them and it will filter out everything other than the transitions that go through that specific state. There's an alternative if you want to click on a state and it will remove that state from the diagrams, the reverse of that there, so you can filter that way. Essentially just a way of building up. If you only want to see everything transmission from IVR to queue to agent, and now everyone here, let's go back. Yeah, IVR, queue, agent, and that's the standard transition. Most people, if you don't hang up straight away, go to the IVR, go into the queue, and then speak to an agent. So then here you can see this is what happens from the standard call. This is mostly what happens, and half of the people hang up, and half of the people they get placed on hold. And then some of those people go back into the queue, some of those people talk to a new agent. You can work out from there. So that's the first type of brushing. And then the second type of brushing is metadata brushing. So as Dylan said, in addition to these sort of states where it's just you're in a queue, you're talking to an agent, there's loads of different other aspects. I mean, the most obvious one is the duration, so how long you spend in these states. So we've got a system that where you can filter based on total length of the call. This is currently total length of the call, how long you spend in the IVR, how long you spend in the queue, how long you spend essentially how long you spend at each each duration. And then this one here, you can't see. I don't know why it's cutting that off, but essentially, as what you talked about, the NPS, the Net Promoter Score, and this is, as you say, a really important metric for the QVC and the customers that and their customers that operate the call centres, because they want to give the best customer service possible. If I'm an internet service provider, the only point of contact I ever have with my internet service provider is when I call up. Normally if I have a problem or if I want to renew my contract or negotiate things. So it's important that that's a positive experience, because if it isn't a positive experience, I'm going to go elsewhere. So this filter now is, we've just applied a filter from essentially filtering out all the non-response NPS callers. So everyone, this whole visualization here now is everyone who responded to the NPS. And it makes sense because you have to speak to an agent to get the NPS text. So everyone here spoke to an agent at least once. So you can apply that. And then we can also, if we drag that further, are we going to do that? I'm not sure if we're going to do that. Yeah, there is, I think we'll show it later. Where we can drag that, we can see all the 10s, all the transitions where people said, yeah, 10 out of 10, that was a fantastic service. And you can also see, the 1s and 2s where people said, oh, that was a terrible service. You can see the difference between the two journeys. So that's the brushing. The next one is the journey tracing. So this feature here, one of the problems with this method and the Sankey diagram in general is that, say you select this point here, you don't really know where all these calls have come from, where everyone who's got to this point. You can say, well, I can see a lot of them came from here, but if you can't go to them come from here, I don't know, it's really difficult to work out their path. So this feature here is essentially just a way of you can hover the mouse over, you enable the feature, you hover your mouse over, and you can see the path. So actually a lot of these people came from there, and this one, yeah. And you can see before, sort of earlier on in the call and ahead in the journey as well. So it's just a neat little feature that sort of overcomes that issue where you can't actually see where the data's coming from. Journey tracing. There's a details on demand feature, so I don't have a video for this. It's nice and simple. You can hover your mouse over any of these states and you can see the numbers of where the states are transitioning in and transitioning out of. Because if you apply a filter and the data goes from 200,000 calls down to 50 calls, the visualization sort of rescales so it's not tiny. So you can sometimes get a little bit lost and think, well, I've applied this filter and it looks like the same number of calls previously. So this details on demand just shows sort of the exact numbers of calls. So currently this agent state, so everyone went from IVR into the queue and speak to an agent. In this data set, 57,000 calls made it to that point. And 57,140 of them came in from the queue. Only 17 of them came in from the IVR and there's no other calls. So yeah, and then you can see where they're going out to as well. So 31,946 of those abandoned, 24,000 of those were placed on hold. So yeah, it's just this neat little feature. In the future work, we're going to create a glyph that sort of sits over these state transitions and incorporates a bit more metadata, and that's going to be sort of yeah, a bit of a future work for us. Hopefully we're going to do that in the next few weeks. Colour mapping. So obviously, you can't have something like this without mapping things to colour. Colours are a very important aspect of all visualization. You should see my talk tomorrow. Oh, I'd single track, you will anyway. Yeah, so we can colour these transitions by any of the metrics. So it takes the average of all the calls in each transition. We're currently visualizing by average duration, it's a colour in the top right, and now it's the average wait time. So this is between 0 and 487 seconds. And you can see that these people are placed on hold in the queue, where it's red here. People have waited a long time, but earlier on, these people hardly waited at all. Yeah. Oh, and you can also, so that's one of the features we added in, is that we found that if we just set the upper end of the colour legend to be the maximum wait duration, because the data is so heavily distributed to 0 essentially, you wouldn't show anything. So we've got these sliders here where you can change the upper and lower bounds of the colour legend. It just makes things a bit easier to analyse. Yeah, so we're just sliding that up now, and you can see the average wait duration has increased. I say you can see that the resolution is projected so bad you probably can't. And you can change. We've got a bunch of different colour maps built in there. So you can change it. We've got colourblind friendly options, we've got diverging ones, we've got lots of different types. And I will talk more about that tomorrow. Okay, so the way we evaluate this software is we go, our company partner QPC, we go up to visit them, we show them the software, we demonstrate it to them, we see if we can find interesting features in their data set, and we show it to them, and they provide us feedback. So they'll say, we tend to do a multi-stage feedback. I think this one was I can't remember what this one, I think we did a Skype sort of feedback session where they said, oh, I like this, or you changed this, or this might be a nice feature. We might implement some of the things they suggested and tweak things and make some changes, and then we do a full feedback session at the end where we collect their full evaluation. So it's one of the observations we got. So this is with the NPS score now. I'm trying to work out what we're going to do. So it's currently the map is currently coloured by NPS. So red is 0 and 10 is green. Okay, currently right. There you go. So what we've just done at the bottom here, you can't see it, we've just filtered out all the non-response calls. So currently, everything you see here is all the responses, and it doesn't really, you can't really work out anything. Maybe this one and this one and this one is a bit darker. These people that finished the call early might be a little bit more green, but it's difficult to tell because on the colour map, all the averages lie around here. So which is why we're now going to change the upper and lower bounds of. Right, are we going to do that? Let's see. Yeah, so we're probably going to change the upper and lower bounds of the. Let's go on. Here we go. The upper and lower bounds of the colour legend. So now we're bringing it 7, 4 and 7. Okay, there we go. So the lower band is 4 and the upper band is 7. So we can actually see now where the difference in the average NPS score comes from. So you can see that people that went from IVR to queue to agent and then hang up the call end here are the people that are happiest. Alternatively, if you go IVR queue, a double queue event is normally when you put into a queue overflow, which meant they probably waited for quite a while, but they're still fairly happy, and that's the end of the call with a higher than average NPS score. And then same thing, IVR queue, agent, hold agent, hang up, they're also quite happy. As you can see down here, all these consult calls, agents calling other agents, imagine the duration drags on for a bit, being placed back into the queue a number of times. A lot of recallers, that's all red down there, averaging out 4, which is obviously a cause for concern. People aren't very happy with it. If we look at the rest now, we'll drag to the right. You can see how it's gone from green to very red now. You can see there are lots, there are lots of different states in this state transitions, then people are going to be unhappy. Yeah. Domain expert feedback. Well, I've discussed the domain expert feedback. That's how we've collected feedback from QPC. This software, actually, this photo. I don't think we had a photo of. Okay, there we go. I don't. We didn't have a photo of our feedback session from this one, but this is the parallel coordinate software from last time. Yeah, so that's how we collected domain expert feedback. I think that's my time there. Thanks for listening. If you have any questions, you can ask them.
Any questions for which RiverState transition things? I have a question. Have you ever considered adding like animation to your RiverState?
Yeah.
I can imagine different kinds of animation, like left to right animation of transitions for maybe a single call or a group of calls, but also like time-based animation where you see the behavior at the beginning of the day and as it changes over the day, for example, or even over a month or something like that. Yeah, I like the idea of, it's one of those ones, I like the idea of having, you press play and you can see in real time the calls come in and this thing grow. I like that a lot. And then the other one that we were thinking of was just a simple animation of making it look like a flowing river. You can see, as you say, from left to right, you can sort of see it move. Just to improve the aesthetics, really. I want to extend this paper for computer submission, so there are a few different ideas that we're working on. So I want to get the glyphs in there, and it would be nice to have the time, time state, maybe have like a slider for the time, the duration, and that might be quite fun. Yeah. I don't know if anybody noticed, but I just saw on my LinkedIn feed quite a viral viz. It's a very simple geospatial viz, and it's showing arms exports from the US and Russia. Has anybody else noticed this thing? This thing is getting massive amounts of shares, and it's very simple. It's just a map of the world, and it's got transitions like you have, but on a world map from where the US has sold like guns and bombs and tanks, like the countries, so a path from the US to all the buyers of military, and from Russia. And the reason it's gone viral is because it's animated. It's the only reason. So it's showing, you know, each sale as an animated transition from source to destination, and it's showing years worth of data. So it looks like a flowing river source or a source of water.
Yeah.
And it's going completely viral. Very simple, but just that animation, everybody loves it. It's very engaging. It's fascinating to watch, and it goes viral just because of the animation. So I happen to
I'll make sure it's
like the idea.
I assume that's legal distribution.
I have no idea. I think that's a very optimistic assumption.
No, I mean the visualization is of legal.
Well, they do cite their data source, but I don't recall.
I'd be surprised if the illegal stuff.
It's fascinating though. It's really historical too, because it goes back to like 1900 or something. It goes back quite a bit, and you could see like ships doing different wars and things like that.
Okay.
Any other questions or comments for Rich? Thank you very much, Rich.